In this video, we'll provide a few tips on circuit breaker selection. The proper sizing of these devices is ultimately your responsibility, of course, but hopefully these tips will help point you in the right direction. Circuit breakers and fuses provide a similar function, but circuit breakers can be much more sensitive to faults. Circuit breakers make it easy to identify where the fault is. You can see that the switch is tripped. With a fuse, you have to disconnect it and test it if it doesn't have some kind of indicator built in. Circuit breakers allow you to quickly restore power. You just flip the switch. With a fuse, you have to replace the device every time. And circuit breakers have more safety options, things like shunt trips, alarm switches, undervoltage releases, stuff like that. The downside of circuit breakers? Well, they cost more to install. But over the lifetime, they can actually be cheaper if you take into account the man-hours spent trying to figure out which fuse blew, equipment lost because it wasn't protected from things like undervoltage, and the cost of the replacement fuses, and more importantly, the time spent finding, ordering, and replacing them. And of course, with circuit breakers, you don't have to worry that somebody put the right size and kind of fuse back in the circuit. Sizing a circuit breaker for use with a motor is easy. In the US, you just go to Table 430-152 of the National Electric Code and look up the answer. For motors, you want to use this inverse time breaker column, which says size the breaker at 250% of the motor's full load amperage. This instantaneous column is for high inrush loads. You wouldn't want to use that with a motor. It would allow the motor to run at 800% of capacity indefinitely. If you're using a fuse on a motor, you would want to use this column for the same reason. MCB stands for miniature circuit breaker, and it's used in low amperage applications on branch circuits in the under tens of amps range. Looks like Automation directs MCBs currently go up to 40 amps, for example. MCCB stands for molded case circuit breaker. These can handle over 10 times that amount of current and are designed specifically to meet the requirements for feeder circuit protection. So if you need to protect a feeder circuit, or you have a need for a large amperage branch circuit, you'll want to get an MCCB type breaker. Looks like Automation directs MCCBs currently go up to 800 amps. The UL rating depends on your requirements. 489 devices are specifically designed for and rated to protect branch circuits, including conductors, control panels, switchboards, motor control centers, things like that. The 1077 devices are strictly supplemental and should only be used where a branch circuit protection is already provided and you just want some extra protection, or where protection is not required but you want to add some anyway. The 489 devices can handle up to 100,000 amps of interrupt capacity. The 1077 devices are in the tens of thousands of amp interrupt capacity, depending upon what voltage you use them at. Circuit breakers are rated using a curve type. A B curve type circuit breaker can handle 3 to 5 times the rated current before it trips. They're great for small switch mode power supplies where you need to be able to handle the inrush current, but need to be in a couple amp range while operating. The C curve has a trip point of 5 to 10 times the rated current. These are general purpose and great for small transformers and pilot devices. The D-type curve trips at 10 to 20 times the rated current. These are used for transformers or high inductive loads like motors that need time to get past the high inrush current without the circuit breaker tripping. Be careful to follow the wiring notes in the specs. There's a separate tech tip video on wiring, but just know that it's really important to follow the wiring guidelines in the spec sheets and that are printed on the terminals themselves. For example, this one shows you how many wires and how many strands in each wire are allowed for each terminal type and temperature range. Also note that they recommend retightening these terminal screws periodically, so consider adding that to part of your regular maintenance schedule. If you don't pay attention to wiring specs, bad things happen, so please pay attention to those and check out that tech tip video on wiring. Sometimes you need to turn off power before opening a cabinet door, and sometimes it's a requirement. Circuit breakers have 2 ways of doing that. One is this rotary handle, which mounts so that when the door closes, the handle mates up with the circuit breaker adapter directly like this, or using an extension shaft like this one. In both cases, there's an adapter plate that transfers the action to the flipping of the breaker switch. The other way is using a flexible handle like this. These work in a cabinet that's specifically pre-drilled for mounting the handle, so it can work in concert with the door latching mechanism. The nice thing about this is you have more flexibility on where you put your circuit breaker in the cabinet. These come with lots of hardware and have built-in adjustments so you can mount them to a variety of breakers. The other nice thing about these guys is you don't have to worry about drilling a hole exactly in the right place to mate up with the circuit breaker. Both of these remote handles give you one other advantage. They make it easier to flip the breaker switch, so you don't have to go get a pair of vice grip pliers just to reset the breaker, especially on those large breakers. Note that some of these are referred to as defeatable. Normally, the switch won't allow you to open the cabinet until the power is off. There are times, though, when it's necessary to access the cabinet while the power is on. Maybe you need to do some diagnostics or some testing. In that case, these are designed so you can bypass or defeat the normal operation of the switch. On this one, you stick a screwdriver in here and twist, and it releases the catch so you can open the door. Beware that you are responsible for any liability if you defeat the operation of one of these devices, and it's assumed that you are fully aware of the OSHA requirements for things like arc flash and personal protective equipment. Sometimes you want to safely trip a breaker remotely. That's what a shunt trip is for. It's basically a cheap way to provide remote or emergency shutdowns, or even just a way to automatically shed loads. Here's an example of an MCB shunt trip. You attach it to the breaker, and then you wire it to a PLC output, or even just a manual switch like I have here. Now you can remotely trip the breaker without opening the cabinet. Once tripped, this device typically disconnects itself electrically, so there's no current flowing through the control wires. And you have to manually reset the breaker after it's been tripped. An undervoltage release, or a UVR, trips the breaker when it senses line voltage is too low. This is handy when you have a system that shuts down and you want to be sure that the system isn't heavily loaded when it tries to start back up. The UVR will have tripped the breaker when the line voltage dropped, so when you go to bring the system back up, this load won't be a burden. Here's an example of a UVR for an MCCB. These are typically mounted inside the breaker here. Once the line voltage is back up, you then go manually reset the breaker. An aux contact gives the PLC a way to monitor the status of the breaker. Here's an example of an MCB aux contact. It just clips on here, so when the breaker trips, this contact closes. Can you stack these MCB style accessories? Well, it depends on the vendor, but usually the answer is yes. For example, here's a shunt trip and an aux contact stacked on a 3-pole breaker. Now we can remotely trip the breaker and monitor its status. This aux contact is a little different because it can detect if the breaker was tripped manually or electrically. This set of contacts tells you if it was tripped electrically, and this set tells you if it was tripped by either. Connect those to PLC inputs, and now the PLC can tell what caused the breaker to trip, a fault or a coworker. If I rotate this little switch right here, now both sets of contacts trip on either manual or electrical faults. Cool. There are a number of other accessories that can tell you if the breaker tripped due to overload, phase loss, short circuit, etc. The point here is there are lots of ways circuit breakers and their accessories can help you quickly diagnose the problems in your system. So check them out. They can save you a lot of time, money, and headaches in the long run. With so many circuit breaker options and accessories, selecting the one you need may seem overwhelming. Fortunately, the Automation Direct website makes it easy. Just select Circuit Protection, and if you want a miniature circuit breaker or the larger MCCB, we'll choose the MCCBs. And now we can specify, do we want everything or just the circuit breakers or just the accessories? Let's select circuit breakers. And now we just choose the voltage we want to operate at and the number of amps we need. And just like that, I'm down to the exact part number I need. For accessories, I can click on that part number and scroll down to the bottom, and there's a bunch of suggested accessories that could go with that breaker. The other way to do it is to come back over here, select MCCB, and this time choose Accessories, and then I can select the component type I want. Let's do a shunt trip, for example, and select the type of breaker I'm using. Let's assume we selected a Fuji, and all of a sudden we're down to 4 possible part numbers, which we simply match up with the series of breaker that we're using, in this case a 250 or 630, and whether we want 24 volt or 120 volt AC control. This parametric search makes selecting circuit breakers and accessories so easy. That ought to be enough to get you going with circuit breakers. As always, if you have any questions, please call Automation Direct's free, award-winning tech support during regular business hours. They'll be happy to help you out. And don't forget the forums. There are lots of folks there that love to share their years of experience. Just don't post any support questions there. Automation Direct's tech support team may not see them.